Hello and welcome to the braking distance revision video from scienceworksheets.co.uk. Please like, subscribe and comment to support the channel. Braking distance is the distance travelled whilst a braking force is being applied to the vehicle, and braking distance is affected by the speed of the vehicle, so the faster the vehicle, the greater the braking distance. Poor brakes or tyres on the vehicle will reduce friction, which increases braking distance. Adverse road conditions, such as wet or icy roads, will reduce friction, increasing braking distance. Explaining braking. A moving car has a kinetic energy store. If you want the car to decelerate and come to a stop, the kinetic energy store has to decrease to zero. So when the brakes are applied, frictional forces of the brakes will mechanically convert the kinetic energy store of the car into thermal energy store of the brakes, as shown in the energy transfer diagram here in red. The greater the speed of a vehicle, the greater the braking force needed to stop the vehicle in a certain distance. If the vehicle is travelling faster, it has more kinetic energy, so more work, energy transferred, has to be done to cause the vehicle to decelerate, so a larger braking force is needed to stop the vehicle. Braking force and deceleration. As the braking force increases, the deceleration will also increase. Remember Newton's second law. Force equals mass times acceleration. So this will mean that the force is directly proportional to deceleration. So as the braking force increases, the deceleration will also increase. Dangers of large decelerations. There are problems with a large deceleration on a vehicle. First one is the overheating of the brakes, and the second one is loss of control of the vehicle. Estimating braking force. In order to make the car stop, work needs to be done, and work done is equal to force times distance. So let's apply that equation to our situation. Work done is equal to the braking force times the braking distance. And the car has kinetic energy. Kinetic energy is equal to half times mass times speed squared. Now the work that is needed to be done to stop the car is equal to the kinetic energy. So work done equals kinetic energy, and we can substitute in work done for kinetic energy, so work done is equal to a half times mass times speed squared. And so now we'll substitute in for work done using braking force and braking distance. So braking force times braking distance is equal to a half times mass times speed squared, and we can rearrange that to make braking force is equal to a half times mass times speed squared divided by the braking distance. You don't need to know how to rearrange this equation, you just need to know how to use this equation to estimate braking forces. Thanks for watching. See our revision notes on this topic, the link is in the description.